Okay, so technically we are recording. We're going to record, and this is going to do a little quick recap of functions, and we're going to look at three specific types of functions. Matter of fact, let me hit my camera as well, if I can. Stop my video. Hopefully that'll increase the bandwidth. But when we start looking at functions, I always like to do graphs. So if you're following along in your computer or on your whatever device you have, can you please go to the website Desmos? We will use Desmos quite a bit. I think I mentioned previously, because we don't have graphing calculators, this will serve as our graphing calculator. So we're going to go to Desmos, and we're going to click graphing calculator. But
Is that in the classroom?
No, just go to the website Desmos. I'll be honest, I forgot to put the link, but it's just Desmos, DESMOS.com. DESMOS.com. Okay. Oh, oops. Let me log in. I forgot I should log in. All right. Now, when I was looking at that chat, what people said about functions are inputs and outputs. But functions specifically, if you want to get technical, it is any relationship where each input has exactly one output. Each input is a relationship where each input has exactly one output. And by inputs, I mean X. And by outputs, I mean Y. So in other words, for every X value, there's exactly one Y value. This is an example of a function because X, if X is 1, the only Y value is 3. So that input has just one output. The X value is 2, the Y value is 4. So that input has just one output. 3 goes to 5. That input has exactly one output. 4 goes to 6. That input has exactly one output. That makes this a function. An example of when this would not be a function is if I had an input with different outputs. Let me take this one in green off. So if we look at this graph in red, this is not a function because this input, 1, that's the same value, it has 2 different Y values. Every X has to have exactly one Y value. So this is not a function. So this example here is not a function because your X value, 1, you have to point 1, 3 and 1, 4. So that X value cannot have 2 different Y values. Any relationship where that never occurs is a function. So like I say, this is not a function. Whereas this is an example of a function. Okay? So, like I say, these are looking at from just ordered pairs. But I saw someone wrote down what we call function notation. This is a way that we write functions. And functions can be pretty much any type of equation. I heard someone mention something about x squared. That is a function. And if I went, every time I got an x value, I get a different y value. That's what makes this a function. I even heard about fractions. Technically, you can have fractions in a function. If I said x divided by 4, that's technically still a function. every x value has exactly one y value. Now, a time when you would not have a function, let's say x squared plus y squared equals, let's go 4. Well, 9, make that a little bigger. This is not a function. This graph, this circle, is not a function. Because if we think about what is a function, every x has exactly one y value. So if I take this x value -2, at -2, the y value is 2.236. But right here, -2, if the x is -2, the y value is -2.236. Since you have two separate y values with the same x, it is not a function. All right. Any questions so far about it being a function or not a function? You can either put it in the chat, because keep my eyes on the chat, or you can unmute yourself and pose any questions. But if you don't want to be on the recording, just put it in the chat, and that will, you won't be on the recording. Okay. All right. So keeping that in mind, that every x has to have a distinct y, has to have an individual y. X cannot have two different y values. One way that we can check to see if this is a function is what was called the vertical line test. If I can create a vertical line, all right, I guess I can't do it. I forgot how to do it here. I'll just do this. X equals 2. Okay, here we go. So notice, as this line moves, how it keeps hitting the graph in two places. If you have a vertical line that hits a graph more than once, it is not a function. So if your vertical line hits the graph more than once, it's not a function. So this is not a function. Whereas this is a function, because no matter where I moved that vertical line, I'm only going to intersect the purple graph once, even if I continued and went further. Or with x squared, this is a function, because the vertical line would only touch the graph one time. This is called the vertical line test. That's important to know when we have functions. Okay, now the function is with the same number, different side. I did not really get it. Same number with a different side. Yeah, so your x, if you have the same x value, your y value, you can't have the same x with different y values. You cannot, if your x value has like different y values, like you have 1 for x, 7 for y, and then 1 again for x and 5 for y, can't be a function. Yes, they will have the same y values, but the x's will be different. Each x will give a distinct y. That's going to be a specific type of function that we're actually going to talk about on Friday, I do believe. Friday, maybe Tuesday. But on a parabola, because if I was to create a table for this very parabola, I'm going to go, oh, I'm sorry, I need to make a table. And I'm going to go f of x3. So no matter which values I put in, like if I put in 2, I just get one value. But if I put in a -2, I get the same y value. But since those x's are different, 2, the only y value that goes to 2 is 4. The only y value that goes to -2 is 4. Y values can repeat. X values cannot. That's going to be the key with a function. X values cannot repeat. Okay. So, like I said, I wanted to do a little recap about what was functions, because I know we've been out of school for a while, and that's not something that's might not be part of our everyday language. So just important to try to see that. Okay. Any other questions, comments, anything? Like I said, you can leave a message if you need a private message, or you can unmute yourself, whichever way. Give you a few seconds just to process. Okay. So I wanted to just kind of recap about functions, about what is a function in general, but we will be going back over these. But I want to talk about 3 specific types of functions today. 3 specific types, wrong button. The first one is called a constant function. A constant function. Constant functions, let me just change this grid a little bit. When we have a constant function, you're going to have a perfectly horizontal line. Constant functions always are perfectly horizontal lines in the graph. It will not angle, it will not be a diagonal, it's going to be perfectly horizontal. But what makes constant functions interesting is that the only variable is y. There is no x. So what this means is this is any point where the y value is 1. So no matter where I went on this line, my y value is still 1. So it doesn't matter what my x value is, as long as the y value is 1. That's why when we have constant functions, because the only thing we need is to make sure our y value is, in this case, like -2.4. No matter where we go, our y value is -2.4. So constant functions, it's going to be y equals some value, some constant value, not a variable. Y equals some constant value, or f of x. Because just as a FY, just for your information, if you see that term f of x, that is the same thing as saying y. But a constant function literally means x is 0. Let me shut this one off. So this means your x is 0. And the only thing you need to worry about is what is your y. So constant functions, the slope of the x is 0. You only have a constant value. And it's always a horizontal line. Okay, good. Okay, yeah. Any other questions just about a constant function? It is always going to be a straight line, always perfectly horizontal. And everything that I'm on the screen, like I say, it is going to be recorded, and I'll upload it to Google Classroom sometime today. Keep hitting the wrong button. Okay, so in addition to constant functions, one that we've done quite a bit, I'm sure, linear functions. Linear functions. Linear functions, I kind of have this down for your old memory. Y equals mx plus b. When you have a slope and a y-intercept, all that good stuff. A linear function. Linear functions will not curve, and you always have a constant rate of change. In other words, your y value is always going to increase by the same amount. So here, my x is 0, y is 1. When x is 1, y is 2, 2, 3, 3, 4. So every time the x increases 1, the y increases 1. Or if I say every time the x increases 2, the y, I'm sorry, every time the x increases 1, the y increases 2. Should be 1, 3. I'll get the point. But that's what the slope is. But it's always linear functions. You have a constant rate of change. And that is literally y equals mx plus b. But one thing that might be a little new and a little different with linear functions is a specific linear function. When you have a linear function with a y-intercept of 0 and a slope of 1, this is called a linear identity. This function right here, or matter of fact, I could do it on this one, where your slope is 1, but your y-intercept is 0, that is called a linear identity. Okay, we're going to go back to linear identities. I think that's whenever we start doing inverse functions. I can't remember exactly when, but a linear identity is literally just when you say y equals x. Because another way I could have wrote that is literally y equals x. If you're saying identity, you're saying just name yourself. So y equals x is a linear identity. So that's the second type of function. Any questions about linear functions or constant function? Okay. And the third type that we're going to focus on today is called absolute value. Absolute value. Kind of quick side note, because that one might be something that's a little less familiar. Anybody remember? Can you either type, or matter of fact, in the chat, can you type in whatever you know about absolute value? What do you know about absolute value? Absolute value. Okay. Distance from 0. Okay. Anybody else? Absolute value. Whole numbers. Okay. All right. Okay. So absolute value technically is defined as the distance from 0. And when we get the absolute value, because it's distance, distance cannot be negative just by definition of thinking of distance. Distance is 0, is 0 or positive. You know, I always like to say when I travel, when we actually, like if I travel somewhere, when I drive to work, I drive 5 miles to work. When I go home, I don't drive -5 miles. It's still a positive 5 miles. Distance is always positive. So absolute value cannot be negative. Let me shut that graph down for a second. And if you see these two bars, these straight up and down bars, that means absolute value. That is literally how far is a number from zero. So like if I say -4, how far is -4 from zero? It's 4 spaces. Yeah. So, but if I take a +4, how far is +4 from zero? It's also still 4 spaces. I don't know how 12 got there. No matter what number I take, if I take -3, it's 3 spaces from zero. If I took a positive 0.25, it's just 0.25 spaces from zero. So absolute value is always distance from zero. And because the absolute value cannot be negative, just the absolute value, it cannot be negative, is going to turn when it gets to zero. So if I get that 0.00, let me take this one off. So we can see that's just right there at the origin. So absolute value is always distance from zero. And if we're doing it with orders of operation, it's like a parenthesis. So if you have operations, what you would do first is you would work inside the absolute value and then multiply and add. But there's a distinct pattern about when we change these values. It's something about absolute value. Notice that original one was a V. It's always a V. As long as you have absolute value in your graph, it is always going to make some type of V. It could be upside down. It might be very narrow. We can make a V that's very narrow. It might be, like I say, upside down. It could be just about anywhere. You know, you can move it. It could be shifted from the left to the right. So when we change the values, only thing we're doing is just kind of modifying the V. It might shift down, it might shift up, but it's always going to make a V. And the reason I mention that, and I'm glad that people are remembering the V part of absolute value, is because we're going to talk about what we call parent functions. And just remember, no matter what that absolute value graph looks like, no matter which way I done flipped it or spun it around, it's still an absolute value. Because literally, this, if I just wrote it, wrote it as absolute value and just substitute it, that's literally -4.8, what's absolute value? X minus -6.9, which is the same as saying plus 6.2. Literally, you get the exact same, but it just has an absolute value. Okay, so whenever we're, just to kind of recap for our 3 functions, constant is always going to be a horizontal line. Always. A constant function. Constant functions are always horizontal. No exceptions. Always horizontal. Linear functions, they are always, they will never curve. They're going to be straight lines. They won't necessarily be horizontal. They'll never be vertical. They can be horizontal, but they never curve. And think about slope-intercept form. Y equals mx plus b. And the last, absolute value, the graph is always going to have some type of V. some form, some way is always going to involve a v. Okay, so those are the three types of functions I wanted to make sure I talked about. I'm going to stop this recording when I get to that part of my screen.